When performing electrical installations for 28-volt DC systems on Air Force bases, several key considerations must be taken into account to ensure safety, reliability, and compliance with regulations. Let's start with wire selection. Use copper wire with thick insulation suitable for DC applications. For distribution wiring, American wire gauge 14 or 16 is typically used, while American wire gauge 18 or 20 can be used for control wiring. Next, consider conduit and cable tray. Install wires in conduit or cable tray for protection and organization. Depending on the environment and specific requirements, you can use polyvinyl chloride conduit or metal conduit. It is vital to ensure that the conduit has proper fittings and reliable ground connections. Now let's look at routing. Run wires parallel to each other to reduce voltage drop and minimize magnetic interference. Keep wires away from high voltage cables and any other potential sources of interference. To optimize performance, avoid sharp bends or excessively long cable runs. When making connections, always use approved connectors and terminals for all wire connections. For enhanced security and to prevent corrosion, solder connections. Routinely inspect connections to ensure proper tightness and sufficient insulation. Grounding is a critical safety measure. Connect all electrical components to an earth ground. Use a dedicated grounding conductor that runs alongside the power wires. Ensure that all ground connections are properly sized and exhibit low resistance to provide an effective path for fault currents. If 400 Hz alternating current work is also involved, it's imperative to ensure that the electrical system is specifically designed to handle both direct current and alternating current. In such cases, use separate conduits or cable trays for direct current and alternating current wiring. Finally, label all wires and components clearly to avoid confusion during installation and maintenance. Always adhere to all Air Force regulations and standards for electrical installations. It is a good practice to consult with a qualified electrician or engineer for specific guidance and assistance. Before energizing the electrical system, conduct thorough testing and inspection. Also, provide proper maintenance and comprehensive documentation for the electrical installation to facilitate future troubleshooting and repairs. In greater detail, selecting the correct wire gauge is important for ensuring that the wiring can handle the expected current load without overheating, which can pose a fire hazard. The American wire gauge system is a standardized system for denoting wire sizes, with lower numbers indicating thicker wires. For 28-volt DC distribution wiring, American wire gauge 14 or 16 is generally suitable, as these gauges can handle moderate current loads over reasonable distances. However, for control wiring, which typically carries lower currents, American wire gauge 18 or 20 may be sufficient. When choosing between polyvinyl chloride and metal conduit, consider the environmental conditions. Polyvinyl chloride conduit is lightweight, non-conductive, and resistant to corrosion, making it suitable for many indoor and outdoor applications. However, metal conduit offers superior mechanical protection and is required in locations where the wiring may be exposed to physical damage. It is also essential to use the correct fittings to ensure a secure and watertight connection. Running wires parallel helps to minimize inductance, which can cause voltage drops, especially over long distances. By keeping wires away from high voltage cables and other sources of interference, you can reduce the risk of electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. Sharp bends in wiring can cause stress on the insulation and increase the risk of damage. Excessive cable runs can also increase voltage drop and reduce the efficiency of the electrical system. Approved connectors and terminals ensure a reliable and secure connection, while soldering provides an additional layer of protection against corrosion and loosening of connections. Regular inspections of connections are important for identifying and correcting any potential problems before they lead to failures. Grounding is essential for protecting personnel and equipment from electrical shock. A dedicated grounding conductor provides a low impedance path for fault currents to flow back to the source, tripping circuit breakers or fuses and energizing the circuit. Proper grounding also helps to reduce electrical noise and improve the performance of electronic equipment. When working with both direct current and alternating current systems, it is crucial to keep them separate to prevent interference and ensure safety. Using separate conduits or cable trays helps to maintain isolation between the two systems, while clear labeling of all wires and components makes it easier to identify and troubleshoot problems. The National Electrical Code provides detailed requirements for electrical installations, including wire sizing, conduit fill, and grounding. It is important to be familiar with the code requirements and to follow them carefully to ensure a safe and compliant installation. In addition to the National Electrical Code, Air Force regulations and standards may impose additional requirements for electrical installations on Air Force bases. These requirements may address specific safety concerns or operational needs. Consulting with a qualified electrician or engineer is essential for ensuring that the electrical installation meets all applicable requirements. A qualified electrician or engineer can provide guidance on wire sizing, conduit selection, grounding, and other aspects of the installation. They can also help to identify and address any potential safety hazards. Thorough testing and inspection of the electrical system are essential for verifying that it has been installed correctly and that it is operating safely. Testing should include installation resistance testing, continuity testing, and ground impedance testing. Proper maintenance and documentation are essential for ensuring the long-term reliability and safety of the electrical installation. Maintenance should include regular inspections, cleaning, and tightening of connections. Documentation should include wiring diagrams, equipment specifications, and maintenance records. The purpose of the earth ground is to provide a safe path for electrical current in the event of a fault, preventing electrical shock and minimizing the risk of fire. The dedicated grounding conductor should be sized appropriately to handle the maximum fault current that could occur in the system. Low resistance ground connections are essential for ensuring that the grounding system can effectively conduct fault currents. This means that all connections must be clean, tight, and free of corrosion. When working with 400 Hz alternating current, it's important to use equipment and wiring that is specifically designed for this frequency. Standard 60 Hz equipment may not operate correctly or may be damaged if used with 400 Hz power. Air Force regulations and standards are in place to ensure the safety and reliability of electrical systems on Air Force bases. These regulations cover a wide range of topics, including wiring methods, grounding, and equipment installation. When designing and installing electrical systems on an Air Force base, it is imperative to consult with a qualified engineer who is familiar with the applicable regulations and standards. This engineer can help ensure that the system meets all requirements and is safe and reliable. Before energizing a new electrical system, it is crucial to perform thorough testing to verify that it has been installed correctly and that it is safe to operate. This testing should include insulation resistance testing, ground impedance testing, and voltage testing. Proper maintenance and documentation are essential for ensuring the long-term reliability and safety of an electrical system. Maintenance should include regular inspections, cleaning, and tightening of connections. Documentation should include wiring diagrams, equipment specifications, and maintenance records. Ensuring the safety and compliance of electrical installations requires strict adherence to industry standards, regulations, and best practices. When selecting wire for direct current applications, it's critical to consider factors such as the current carrying capacity, voltage drop, and environmental conditions. Copper wire is generally preferred for direct current applications due to its high conductivity and resistance to corrosion. The insulation should be rated for the voltage and temperature requirements of the application. Proper conduit installation is essential for protecting wiring from physical damage, moisture, and other environmental factors. Conduit should be securely fastened to walls or ceilings and should be properly grounded. Sharp bends in wiring can create stress points and increase the risk of damage. When routing wiring, it's important to avoid sharp bends and to provide adequate support for the wiring. Approved connectors and terminals ensure reliable and secure electrical connection. These connectors should be properly sized for the wire gauge and should be installed using the correct tools and techniques. Soldering connections provides a permanent and reliable connection. Soldered connections should be clean, smooth, and free of voids or cracks. Regular inspection of connections is essential for identifying and correcting any potential problems before they lead to failures. Connections should be checked for tightness, corrosion, and damage. Grounding is a critical safety measure that helps to protect people and equipment from electrical shock. A proper grounding system provides a low-impedance path for fault currents to flow back to the source, tripping circuit breakers or fuses and energizing the circuit. Working with 400 Hz alternating current requires specialized knowledge and equipment. This frequency is commonly used in aviation and military applications. When working with 400 Hz alternating current, it's important to use equipment and wiring that is specifically designed for this frequency. Air Force regulations and standards are designed to ensure the safety and reliability of electrical systems on Air Force bases. Consulting with a qualified electrician or engineer is essential for ensuring that the electrical installation meets all applicable requirements. Testing and inspection of the electrical system are essential for verifying that it has been installed correctly and that it is operating safely. Proper maintenance and documentation are essential for ensuring the long-term reliability and safety of the electrical installation. In summary, always select the appropriate wire gauge and insulation for the specific application. Use conduit to protect the wiring from physical damage and environmental factors. Route wires carefully, avoiding sharp bends and excessive cable runs. Use approved connectors and terminals for all wire connections. Solder connections for enhanced security and corrosion prevention. Ground all electrical components to an earth ground. Separate direct current and alternating current wiring when working with both systems. Label all wires and components clearly. Follow all Air Force regulations and standards for electrical installations. Consult with a qualified electrician or engineer for specific guidance. Test and inspect the electrical system thoroughly before energizing it. Provide proper maintenance and documentation for the electrical installation. Now consider the specific details concerning DC systems. Direct current electrical systems have unique characteristics that require specific attention. Direct current voltage drop is generally more significant than alternating current voltage drop over the same distance. Therefore, careful wire sizing is crucial. Direct current systems do not have the same skin effect as alternating current systems, meaning that the entire cross-sectional area of the conductor carries current. This can impact conductor selection. Direct current circuits can be more susceptible to electromagnetic interference if not properly shielded and grounded. Now consider wire selection in greater depth. The choice of wire gauge depends on the ampacity required for the circuit. Consult the National Electrical Code Table 310.16 for allowable ampacities of insulated conductors. Also consider the ambient temperature and dirtying factors as per the National Electrical Code Table 310.15. The insulation type should be suitable for the environmental conditions. Common insulation types include thermoplastic high heat resistant nylon-coated, cross-linked polyethylene, and rubber. Consider using shielded cables for direct current circuits to minimize electromagnetic interference, especially in sensitive electronic applications. Now think about conduit and cable tray. Metallic conduit provides better mechanical protection and electromagnetic shielding compared to polyvinyl chloride conduit. However, polyvinyl chloride conduit is corrosion resistant and lighter. When using metallic conduit, ensure proper bonding to maintain ground continuity. Cable trays offer flexibility for routing multiple cables but should be used with appropriate cable ties and supports. Let's now cover routing. Minimize the length of direct current wiring runs to reduce voltage drop. Keep direct current wires away from alternating current wires to prevent interference. Avoid running direct current wires near sources of heat or vibration. Now, consider connections. Use crimp-on connectors that are UL listed and properly sized for the wire gauge. Apply anti-corrosion compound to terminals and connectors to prevent corrosion. Torque connections to the manufacturer's specifications to ensure a secure connection. Next is grounding. Use a dedicated equipment grounding conductor that is sized according to the National Electrical Code Table 250.122. Connect the equipment grounding conductor to a grounding electrode system that meets the requirements of National Electrical Code Article 250. Measure ground resistance to ensure it is within acceptable limits, typically less than 5 ohms. Let's now talk about 400 Hz work. 400 Hz alternating current systems are commonly used in aircraft and aerospace applications due to their compact size and weight. When working with 400 Hz alternating current, use equipment and components specifically designed for this frequency. 400 Hz alternating current systems require specialized wiring and grounding techniques to minimize losses and interference. Next up, additional considerations. Review all applicable Air Force regulations and standards for electrical installations. Obtain necessary permits and approvals before starting any electrical work. Document all electrical work, including wiring diagrams, equipment specifications, and test results. Finally, remember the test and inspection. Perform insulation resistance tests on all wiring circuits before energizing. Conduct voltage and current measurements to verify proper operation. Inspect all connections for tightness and proper insulation. By following these guidelines, you can ensure that the 28-volt DC electrical installations on Air Force bases are safe, reliable, and compliant with applicable regulations. Remember to always prioritize safety and consult with qualified professionals when necessary. Also keep in mind that the information provided is a general guide and specific requirements may vary depending on the application and location. It is essential to consult with qualified professionals and adhere to all applicable codes, standards, and regulations.